We're going to look at linear problem solving, and we're going to focus on the question that says speed of a boat in the current. So we're going to read it over once, and then we'll pull out what's important information. So Katrina rows a boat downriver 10 kilometers in 2 hours. On the return trip, it takes her 4 hours to row 8 kilometers. Determine her average rowing speed and the speed of the current. So this one's pretty straightforward for the numbers. She goes 10 kilometers in 2 hours when she's going downriver. And that's actually going to be really important to us, which way she's going. And then on the return trip, so we assume she's going upriver, and it takes her 4 hours to row 8 kilometers. And we want to know the speed. I guess we'll do a different color here. We need to know the speed of the current and also her rowing speed. Okay, a lot of information. Now, what we're going to do is take a formula that we usually taught in science. Do you know the formula for the relationship between speed, time, and distance at all? Okay. So if we were to drive a car, let's say, okay, so I'm driving my car and I want to find out how far I'm going. I have to multiply how long I travel and at what speed I travel for. So we say speed, we'll say S is our speed, and we could say that our T is our time. Okay, so distance is D. S is speed. Ooh, let's spell that right. There we go. And T is time. So, that one is not bad. We have a lot of the information here. Do we know what the distances are? Do we know how far she rows? How far does she row downriver?
10K.
Okay, so we're going to do this twice. Okay, so we have one speed for downriver. Okay, so imagine that you're on a boat. Okay, and we're going downriver, so that means you're going with the current. So that'll be our first one. Okay, and they go 10 kilometers, but we don't quite know the speed. But we can figure out the time. How long does it take her to do that?
In 2 hours.
Yeah, she does it in 2 hours. So our time now is 2 hours. She does it in 2 hours, and her distance was 10. That works out good. And our second one, it's the exact same formula. So it's distance equals speed times time. But this time, the river's still going the same direction, but we're going up. We're going upriver. So the current is against us, which is going to play into this. Do you remember what the distance was going upriver?
8 kilometers.
Yeah, it's 8 kilometers. So our distance is 8 kilometers. Yeah, and how much time does it take?
4.
4 hours. Okay, so it took us 4 hours. Now, the tricky part about this is the speed. The speed depends on two things. It depends on our rowing, and it also depends on the current. So speed itself is not just one number, it's two things. So we're going to break the speed. Our speed is however fast the current is going and however fast we're going. So we're going to say how fast we're rowing. But it's also dependent on what direction we're going. So if we're going downriver, that means the current is helping us. Okay, so the current is increasing our speed. Okay, so we assume we do the same speed and the current helps us. If we're going the other direction, okay, the current is actually slowing us down. Whenever we're rowing, the current is fighting against us, so we take it away from our speed. So our S, we have to plug both of these in for the S, depending on what direction we're going for the equation. Okay, so this is a very confusing one to set up. So we'll start with here. Our equation 1 goes 10, and we said they were going downriver. So which of these two do you think we use? The current plus the river, or the
Current plus the river.
Sorry, not the current. The rowing speed plus the current, or the rowing speed minus the current?
Rowing speed plus the
Yeah, because the current is helping us when we're going downriver. So we replace S. Okay, so we replace the first S, we'll do it in green, with this one here. Okay, so that becomes rowing speed, and I'll put rowing speed first so it makes a little more sense. Our rowing speed plus the current, and it takes us 2 hours, okay? And I can put the 2 in front or behind, it doesn't make a difference. And for our other one, we are going 8 kilometers, we'll put the 4 in front also. And which of the two speeds do we use? Do we use the current plus the rowing speed, or the rowing speed minus the current?
Rowing speed minus the
Yeah, that's right. So for this one, because the current is hindering us, we use the rowing speed minus the current. Okay? So now we have two equations, and technically we should be using distributive property to help us out here. Okay? So equation 1 now becomes 10 equals 2R plus 2C. So C is current, R is rowing speed. And 8 equals 4r minus 4c. Okay? And from here you would choose to either use elimination or substitution. There we go. I would suggest that we probably use elimination. Yeah, because we can change our coefficients pretty easily. So what I'm going to do is I'm going to change the first equation to have coefficients of 4. Okay? So that means I'm going to multiply the very first equation, everything in it, by 2. Good. So write that down here. So now our first equation times 2 becomes 20 equals 4r plus 4c. And our second equation is 8 equals 4r minus 4c. Okay? So we have to decide whether we're going to add or subtract. Because these ones are both positive, if we subtract, we'll get rid of the r. But also these coefficients are the same, but one's positive, one's negative. So in that case, if we add, these two will disappear. So it just kind of depends on which one we want to eliminate. Which would you like to eliminate? Doesn't matter. It doesn't make a difference. What would you prefer to do? Add equations or subtract them? Let's go with add. Add's usually the easiest thing. So let's add the two equations together. Okay? So our first one, what's 20 plus 8? We put it 28, good. 4r plus 4r. 8r. Positive 4c plus negative 4c.
0.
Yeah, it becomes 0c, which means nothing. So now we can isolate for r. How do I isolate for r? Divide by 8. So we get r is equal to, it's not the nicest number. Let's find out here. 28 divided by 8? No. 3.5. So our rowing speed is, that's okay, 3.5, and then we assume it's in kilometers an hour.
Yeah.
Okay? Now that we have the r, what do you think is the fastest way to figure out our c? We know that r is 3.5 kilometers an hour. Yeah, we would substitute it back. We could eliminate again. We could actually go right back to this step and then subtract the two equations, and that would get rid of the r. That rarely happens in elimination. Substituting might be a really fast way to do it, so let's do it. Let's choose. Do you want to use equation 2 or equation 1 to substitute with?
1.
1? Okay, so equation 1, 10 equals 2 times what?
3.
Yeah, because that's the rowing speed. Plus 2c, and then here we go. 2 times 2.5 is going to be 7. Okay, so 10 equals 7 plus 2c. We bring the 7 over. 10 subtract 7 becomes 3. Are you okay with that, or is that too fast?
Mm-hmm.
That's okay. 2c. And then how do we isolate 2c?
Divided by
2. C becomes what? Do you know? 1.5. Right? So the current speed is 1.5 kilometers an hour. This is a really tricky question to set up. So really, the eliminating part isn't the hard part at all. We're really good with it. It's this setup here that becomes important, and how we split the speed depending on what direction we're going, which is the hardest thing to do. We can thank Gabriel for all that extra.
How did you